Okay, so that was the Mickey. And finally, I was able to give it a big tick. Now, I thought I was pretty smart, and I had high expectations of Australian radios. So the next thing I got was the 500MY. Well, I think it was an MY. I couldn't find any branding on the back, but someone said, oh, that's an MY. So I thought, okay, 500MY. Great. Circuit diagram. It's got back bias, and it's got two back bias resistors, which tells me it's getting two separate DC voltages out, and that implies that one's going to be for the output stage and the other one's going to be for the converter and IF, yeah? So I need about -12 for the 6v6, which is probably what that is. Negative voltage goes up to the grid, into the grid of the 6v6. Why did they draw the circuit that way? Probably so that I would ask the question. Gosh. And then there's a tapping, and that appears to go, yeah, okay, so what they've got is they've got about -12 for the output valve, and they've got maybe -2 or 3 for the IF, and the same about -2 or 3 for the converter, but that's modified by the AGC output. So it should be pretty simple. So all the valve cathodes go to ground because they've got a back bias supply. Okay, another one. Someone who just, in fact, this was worse. Just tied a knot in the damn thing and just let it wiggle around. So you can probably guess what I did. Put in the cord grip. Okay, power on. The volume pot's a bit scratchy, but it was quiet. Now, for any radio that's got 4 or more signal stages, 5-valve Mantel or a 6 transistor set, turn it on. Even if you're out in the middle of the country, when you turn the volume fully up, you should get noise coming through from the front end. Here in the city, there is so much electromagnetic interference, what I call the electronic fog, that you're probably going to be stuck to find a part of the band where you're not getting all that stuff crashing in. So if you've got a set, put it on the bench, turn the volume up and you get nothing out, I went, there's something wrong. This set is really, really deaf. It's not working properly. So that was the assumption I went in with, especially remembering that I had that image of the excellent performance of the Mickey in place. And the 500M. Here's me thinking, well, can't hear anything, volume pot's a bit scratchy, what a rubbish set. Got to be something wrong with it. Check the HT. It was all right. Good, so I'm following my thing of doing the DCs. Audio into the output grid is about okay. About a volt on an output valve should give you about 15 volts at the anode or about 50 milliwatts, whatever. By the way, I tested at 400 hertz because I found some sets with really aggressive bypassing and tone control and stuff. The response is actually starting to fall off by 1 kilohertz. So 400 hertz, and as well, if you're running a speaker, 400 hertz is not as annoying as 1K. And then the penny drop. It's only got one audio stage, right? So of course, it's not very sensitive. Okay, check the rest of the set. And I'm going, where's all the back bias on the output valve? Well, here's what I found. There's no back bias on the output valve grid, so that's why it was at 0 volts, not about -12. And this particular set had cathode bias. So here's me thinking it was a 500MY, and I discovered the 500M. Okay, back to know your beast. I didn't have an identifier. Someone said 500MY. I launched off in that direction, then came back once I discovered that the output grid was at ground. The set shouldn't have been working, but it was cathode bias, so that was perfectly okay. Did the alignment? The alignment came up okay. We tend to think of alignment as just getting the set in trim, but as well as that, if you tweak the screw or adjuster on an IF can and you don't get much change in sensitivity, that's probably a crook-tuned circuit. If you tweak an IF can and you see the output come up and go down and comes to a really nice peak, that tuned circuit is probably okay. So you're going to do the alignment anyway, but just be aware that's also another valuable diagnostic. If a particular circuit won't align up, you must suspect that it's faulty. And this one had an IF filter. I thought, I know what to do about IF filters. I'm going to pull the thing out. It was an absolute disaster on the Mickey OZ. It's got to be what's compromising the performance on this little AWA set. So I went to the IF filter, and it's that one, L1C1, pulled it out, and you know what? Made no difference. So this was one case where the dreaded IF filter that so many people say is compromising performance, it was actually properly designed and taking it out didn't have any effect. So again, I was coming in with my Mickey OZ high performance IF filter compromising performance, and I discovered once I looked at the circuit rationally and understood what this radio was, that was a misconception. So the circuit stayed as was. And okay, it's a 4-valve set, that's all it is. 3 signal valves, it doesn't have reflexing, so of course it's not particularly sensitive. It's a Mantel radio meant for suburban or country town use. It's not a radio that would perform suitably in the outback as the OZ probably would have done. It's a budget set. So any comments on that one?
One thing
on
these 500 series sets, Michael Justin has done a talk on that, which is in my long list of videos to put up on the website.
Oh, good, okay.
He talks a lot about these and the problems they have. He used to work on them at the factory, or in the repair section of the factory down in Melbourne, and yeah.
Okay, thanks Andrew. So appearing on the website, which Andrew will be putting up fairly soon, or when time permits, yeah. Mike Justin, who used to work on these sets, will be talking about that particular model. I like it. It's a really nice looking little set. I had an article in Silicon Chip, I think it was last month, and I call it the bookshelf radio. It looks really nice in amongst a whole heap of books. It's very neat, very decorative, but just remembering that it's a town set, it's not a country set. All right. So this one was thanks to Andrew. It's a Philips 172, nice looking set, and it's a proper 5-valve with 4 signal stages. Andrew had been through and done a recap. Would you like to comment on it, Andrew?
It's got permeability tuning. What do you mean by comment on it?
Anything, well, the repair was fairly straightforward, or?
I've done quite a few of them, so I don't really remember this particular radio, but I've done everything on it, and it was still deaf as a post. So I couldn't work it out at all, and so I handed it across to Ian. And
here Ian takes up the story. Yes. So, and what Andrew said there, the principal symptom was it was a bit deaf. So it's a 4-valve set, turn it on, let it warm up, turn the volume up full, getting just about nothing. Well, we know that's wrong. You should at the very least be getting the internal noise from the front end of the set. In any suburban setting, and maybe even now out in the country, you're going to get that electronic fog crashing through. You may have seen my article on the screen room. That was the reason I built the screen room, because I couldn't get a set in an electrically quiet environment that I could be certain that whatever noise I was seeing on the oscilloscope or on the meter was due to the set itself rather than the fog. So this set, deaf. Okay, well, so Andrew had done a recap. He'd checked all the HT. He'd done the IF and local oscillator alignment, so it should have been everything that was required. Well,
and also, as I said, I've done a number of the sets, And I've done everything exactly the same as the other ones, and the other ones were working beautifully.
Okay, so what was wrong with this one? All right, okay, let's do signal tracing. I use a watt meter, but you can use a AC voltmeter, 0.1 microfarad blocking cap into your meter, and you're looking for around about 15 volts on an AC set. And about a volt of audio signal on the 6M5 grid gave about 15 volts, so that stage is working about right. So I've ticked the grid, give it a tick there, about a volt there. So I went down to the volume control, expecting maybe, 10, 20, 30 millivolts. And I was disappointed. I needed over 100 millivolts onto the volume control to get my 15 volts output. And then what was really weird was I thought, it's my 0.1 microfarad coupling cap that I always use on a SIGGEN. I'll pull it out and put in a 0.01. Okay, now I needed even more voltage to get my 15 volts out. What the hell's going on here? So I gave up on the signal and I went back to what are the DC conditions. The anode voltage was a bit low and the grid voltage was about half a volt positive. Gosh, I know that's wrong. So the grid voltage is usually a bit negative, right? In most audio circuits, they just let the grid drift weakly negative with a 10 meg or maybe 4.7 meg grid resistor. It's called contact bias or Edison potential or something. It's a real simple method of doing it, and for triodes and some other valves, you just put that 10 meg resistor, it'll drift around about a volt negative, and it'll work okay. This one was plus 0.5, and that's absolutely not correct. So what was happening was the grid was forward biased, which meant it was acting as a diode, which meant it was conducting, which meant any signal you tried to present to it was being shunted to ground to some extent. So that was why I needed heaps and heaps of signal at the volume control to get the output I was expecting. So I pulled out the valve and the grid voltage dropped to 0. Turns out that there was leakage in the valve, so I got the valve, toothbrush, bit of Jif, scrub, dried it all off, hairdryer, put it back in, still no better. So what it turned out was there was internal leakage inside the valve itself. Now, some of you may know that the 6M5 is notorious for developing internal leakage. I'm getting a couple of nods here, sorry. That was... Yeah, okay.
And external leakage on the M5 as well, and they solved it by not silvering the pins all the way to the glass. It tracked across between the pins externally.
Also, what the silvering was internal?
They silvered the pins,
Yeah.
and they had the grid and the plate pins close to each other, and the silver migrated across the glass.
Okay.
And there's a factory note that came out saying they'd solved it by not silvering the pins all the way up. They're just fractionally short of the glass, and it stopped it occurring.
Okay, so, and this is on the actual outside of the envelope. Okay, I didn't know that. So that was, so that, again, I guess that was a factory error where they found eventually. Now, I didn't know about that, Kevin, but that would certainly explain it with this one. Because I was unaware of that, I didn't try to recover it.
Something in radio waves a while back about basically hooking it to a power supply and burning that silver away, and basically saving the valve.
The hairy-chested approach. We'll zap it out. But seriously, I mean, if that's a remedy that ought to work, yeah. So this was the first time I'd ever encountered it. So my solution was I just replaced the valve. And once I put it back on the bench, the grid voltage drifted about negative, I think it was about minus half a volt, and checked the rest of Andrew's work on it. Yes, the alignment was good, everything was good. It's quite a good performer. So that was an unusual one, but it's one that we now know about. And I think, Kevin, and it's particularly those Phillips valves with the flat disc base and the pins, because a lot of other valves, if you look down the envelope, they round off slightly as they hit the disc seal. but the Phillips ones are quite flat where they join.
Correct,
Yeah. So,
If I remember correctly, it was a Phillips service technician's alert.
okay.
And it was just one paragraph about 6M5 and what they'd found, and that they'd rectified the fault by not silvering the pins all the way up.
Okay.
Not migrating across the glass.
Yep, yep. Okay, so, any comments, questions, stuff? Yes?
Would that have shown up on the valve tester if you just tested the valve?
No, it didn't. Not on mine anyway, but might on the Avo.
Okay, so I'm not certain. I didn't. I actually should have been thorough enough. It should have shown as a leakage test from grid to something. I didn't go as far as testing that, but if anyone has got a dodgy 6M5, it would be interesting to pop it onto a tester such as the Avo, which does do leakage testing, and just confirm whether a valve tester will detect it. Because if the valve's otherwise good, it seems a pity to bin it if it's only that leakage, which may be remedied fairly simply. Yeah.
Just got a valve question. I recently replaced a 6U7, which is the first audio, which appears to be intermittent, that particular valve. And when you said, they said it's dead, you got no audio, so you put your finger on the cap of the valve, which is the grid, and there's nothing. Pull the chassis out, put it on the bench, and of course it works.
Yeah.
Put it back in the cabinet, and it doesn't work. Anyway, after a bit of mucking around, I ended up changing the 6U7 first audio, and it seems to be fine since then. But it's like it was an intermittent valve. Has anyone come across that?
I've found it in transistors, not in valves, because usually...
No matter what I could do, I could bang it on the bench. I could not make it fail on the bench.
Okay. Some people have said that they've gotten radios to work just simply by taking all the valves out and just tipping them upside down, going and re-soldering all of the connecting wires.
So I cleaned the pins in the socket, but it's still, and since I've replaced the valve, it's worked fine.
No, that's not one I'm familiar with. Did have a Sony transistor radio where one of the transistors, if you gave it a good solid tap, the radio would work, or not. And the only thing I can work out is that the one of the internal leads inside the case was only just making contact. But no, I've not heard that with valves.
Maybe, like you said, resolder the pins.
I think that's worth a try. You'd expect them to be as good as, but particularly if you don't have a replacement valve, I think it's certainly worth popping it out, putting it upside down securely, and just going around and redo the pins. Yes.
When the valves are manufactured, the leads that come out of the pinch are very heavily tarnished because of all the heat.
Mm-hmm.
So the manufacturer relied on with a very active flux, but it sometimes doesn't break through the tarnish. And the only bit that's soldered is where they snip off the extra long length, and that's the only bit that takes the solder to the nickel-plated pin. So sometimes you've got to extract that solder with solder wick, run a needle file down the hole, and clean up that wire.
Okay, so the issue is one of process. The leads coming out of the pinch have been exposed to heat, they've oxidised, and like you said, they use a very aggressive flux in the solder to clean that oxidation off, but that's not totally reliable. Yeah.
And the top cap is also the same. You'll sometimes extract all the solder from the top cap connection, and the wire doesn't appear to be tinned. So give it a scrape and away it goes.
Okay. Yeah, because, well, that's all...
With those circuits, that 10 mega ohm resistor has got to be good, because that value of resistor will sometimes go over circuit, depending on the brand.
Okay, well, so I guess that's another unexpected thing. It's in a no-stress application. It's got no voltage, no current, so how come it goes crook? And I guess it's what, just aging? Yeah, I guess, yeah. And that's where what you were saying about checking all the resistors, that would actually detect and eliminate that particular fault of a resistor that, look, well, personally, I'd go 10 meg grid resistor, how can that possibly go open? Well, it can age open, and my approach wouldn't necessarily find that until I came back and did an exhaustive analysis of what was going on there. Yeah.
I found a lot of them will actually go down to 3, 4 meg or something like that from 10.
And that's if you've removed one end and measured just the resistor? Okay, well that's unusual.
No fingers anywhere near it.
Yep. I'm familiar with resistors going high, but what you're saying is they can go low. So I guess your approach of going through and actually checking components is exhaustive and should turn up any weird faults like that. Yep.
That was checked. So
Sorry?
that did check out, I remember that. So that resistor did check out as 10 meg.
Okay. All right. Look, I've just got a couple of final comments. Has anyone else got things they'd like to say?
I've got one.
Yes, Kevin.
Just a general comment. Back in the 70s when I was working for a company and we had a boss and all that sort of stuff, you were paid to troubleshoot down to the component level, down to the individual component.
Yep.
Now, obviously these days a lot of the stuff has now moved on another 50 years from then, so a lot of the wax paper stuff, your electrolytics, all that sort of stuff, to shotgun those is a good move, and the price of it is relatively cheap.
Yep.
The only thing it doesn't do is doesn't teach you fault finding. So what you were saying, where if you protect the circuit by a variac or whatever it means, it's good practice to follow that through to fire the setup and actually fault find what the problems are.
Yep.
And there'll be lots, there'll be lots. You certainly eliminate most of those issues by changing out the caps and checking all your valves and so on. There's not a lot left in there, and you say, I'm a technician, I'll fix this radio. But it hasn't taught you a lot. Right, so you can protect the radio and you want to learn. That to me is, if I was to teach somebody, that's what I do. Do it that way. If I'm just doing a quick repair for myself, I'll shotgun it too. But sometimes you go, I'm getting a bit lazy here, I'm just changing everything, and it's not taught me anything.
Yep. So I guess if I go back to my approach that's in the handout, that will definitely get you a properly working set. You do need, like I said at the start, to know your beast. You need to have realistic expectations of what it'll do. Don't fall into the trap that I did with the Mickey of thinking, oh yeah, 1933, come on. They've only just patented the pentagrid. There's only been a few years of development of that particular converter technology, so after only a few years, how good is the converter stage going to be? Well, probably pretty poor. If you're familiar with the set, the IF cans don't have a top in them. They're just these sort of square cans with stuff stuck inside, and it looks pretty agricultural. So my first look at it was, yeah, 1930s, Astor, who cares, it's going to be pretty rubbish. And that was a mistake, which I found out through detailed investigation. There's also a really unusual thing about it, which is in the article. They actually use regeneration, positive feedback, in the converter stage. Yeah, I looked at the circuit and I'm going, that's got to be wrong. It didn't look like any converter circuit I'd ever seen, but that's because it uses positive feedback in the converter, and that brings the gain up by about 3 or 4 dBs, just like that. So you need to be careful about expectations. You need to look at the actual as-built set and understand it and respect what it really is doing. Likewise with the 500M. Whacked it on the bench, still had the Mickey gears in my head, and went, oh, this is rubbish, who built this stuff? And then when I finally gave the set its due and looked at it and analysed it, it's actually a pretty good Mantel set designed for the city. And what Andrew did with his Philips, he did everything right. It's just that there was that really weird thing which, like I said, I've never seen in signal valve, where there was that leakage between the pins. So I'll finish off with just a few comments. Firstly, don't be a slave to procedure. If you know the rules, then you've got much more flexibility and much more agility in being able to deal with complex problems. Secondly, my basic approach is the output to input. If you've got a crook speaker, don't start fiddling with the aerial coil because you're just burning daylight all the time. So output, back to input. There's also a technique called the half split, and the superhead is ideal for that because you've got an audio stage and that's pretty easy to diagnose, and there are, as shown in the handout, signal voltages you can expect, and the rule of thumb is any radio set with 2 audio stages, somewhere about 10 to 30 millivolts at the volume control should give you the 50 milliwatts output. So the superhead is ideal for that. And I often don't go through in great laborious detail. If the AF circuit is working about right, I keep heading forward. There's nothing to adjust in the audio circuits. So if everything looks about right, it probably is about right. And you can put more effort into the more complicated part, the front end, where you do actually have a number of adjustments or alignments that you have to do in concert. Some people ask me about signal tracers and signal injectors. I don't tend to use them because the signal injector is just like a square wave waveform. You can put a signal injector on the antenna terminal of a superhet where the local oscillator is dead, and you'll probably get a squeak out of the output. So I don't consider them to be particularly indicative. Likewise, signal tracers work probably okay in the audio. The closer you get to the antenna circuit, the less likely you are to have much luck, because in a good set at the converted grid, you're probably getting 50 microvolts or less, and a signal tracer won't pick that up. You might have seen my workshop with that array of equipment, all that stuff Ian Batty's got. I think all you really need is 2 good multimeters. An analog one, if you need to find peaks, you can watch the needle and you can peak on the needle. If you need to take voltage measurements, a digital one is a lot quicker, 23.5, 35, 142, 170, 0. You'll get more accurate, more importantly, you'll get much readier readings straight out, rather than having to look at the analog meter, oh, I've got to switch ranges, da-da-da-da. But remember, the analog meter is ideal for picking peaks or dips. Audio generator, 20 hertz to 20k is really all you need. 0 to about 3 volts will do just about everything you want. Preferably calibrated so you can actually compare measurements. For the RF section, an RF generator, I've got an HP fully digitally synthesized stuff which I love. The only problem is, if you've got a set on the bench and you think, oh, it's about 600k, you go tap, 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 I missed it, tap, tap, tap. My advanced analog generator, switch it on to broadcast and I go, it's just there. So an analog generator with a calibrated output, preferably, so you can get an idea of how well the set's working, is perfectly adequate. So what do you need? You need analog DVM, or analog meter, digital meter, audio generator, and an RF generator preferably calibrated. That will do pretty much everything. I do more detailed analysis, but looking back, I could have fixed the Mickey and the 500M just with those 4 basic pieces of test equipment. More is nice, but don't get sort of intimidated by the fact that some of us have got all this stuff. These radios are fairly well known. So long as you can get the circuit and have reasonable expectations for what it should be doing, your basic test equipment will do perfectly well. And I think that's about all. I'll just remind you that there's a number of sources, particularly of Australian stuff. There's Kevin Chant's website. It's the way it's spelled, Kevin Chant. You'll find him pretty easily if you Google. And there are the circuit books available through our valve bank. As well as that, I haven't got the valve book, but there's How Your Radio Works, which is the valve version of this, which takes you from Lee de Forest all the way through to modern radios. And there's that one, which is the transistor equivalent. Any final questions?
Your idea of using a second radio to check
the
oscillator is excellent.
Yes, so you've got a set and you're going, it's not working. And then you think, it's a superhet, so The secret source in every superhead is in there somewhere. There's this tiny little transmitter. So you've got a set and you're not sure if it's working. It sounds a bit deaf. The audio's sort of working because the volume control is scratchy, but you'll fix that later. Is the converter working? Because if that's not working, you've got no show. So what you do is you get your oscilloscope and you put it on the converter grid and you don't get anything. Well, it might be that your probe has just stopped the oscillator from working. So you think, no problem, I'll get my multimeter. You stick that on the converter grid. Sometimes the converter will keep going, sometimes it won't. You must expect you're going to push it off frequency. And it gets even worse if you've got a UHF set working at 450 megs and you've got no idea. So what you do is you get another radio in the same band, AM radio, good transistor or valve set, turn it on, tune to about 1500K, turn on your suspect set, dial up to about 1 megahertz, 1 plus 0.455, somewhere around about 1 megahertz on the suspect set, you'll get the oscillator going whoop, whoop, or blanking or something. That'll work on any superhet radio, valve, transistor or stuff yet to be invented. It'll work on any superhet radio from long wave, medium wave, high frequency, VHF, UHF. It'll work on any set. It's a quick test and it is indicative. If you can't get that response, then you must suspect the local oscillator. Yeah, thanks for reminding me.
The other thing I use is handy, I've got a telephone butt, which is what the telephone technicians used to use. They're about 3,000 ohms. You know, the red handpiece.
Oh yeah, yeah.
You can just clip that onto the volume control and listen to the front end straight away, you know.
Is there enough?
So if you've got dead audio, there's two types available. We've got two. One's a rotary dial one, which is just a, you know, you can hold it to your ear. The other one has got a battery and an amplifier, and you can actually put it on speaker mode. It's basically a portable amplifier. But I've seen them for sale from time to time, and they're useful for that.
So the old-fashioned PMG Liney's handset, the earphone is sensitive enough to pick up off the volume control. Okay, wow. Excellent. I think I'll get one. Okay, anything to finish with? Kevin.
One fine one for me is, I'm not sure if you've ever seen Mr. Carlson's lab on YouTube.
Well, I don't know that I have.
He builds a super probe which just has a shaft with a little coil and that sort of stuff. And you put it near the valve and you can tune the radio, even if the radio is not working. It'll tell you whether the oscillator's working. It'll pick it up and bring out a super sniffer.
Oh, okay.
Run it along the valves and it'll tell you where the signal stops without even getting your multimeter out of the box.
Good. So what was the site again?
It's Mr. Carlson's lab.
Mr. Carlson's lab.
And then the board and everything available. He's made all the artwork and then available as well, so you can order that and put it
On YouTube.
Yes.
Mr. Carlson's lab. Okay.
He's Canadian.
Okay.
I'm not sure which coast he's on, but he's mad. He's got a whatchamacallit, a bucket lifter thing. What do you call that? Cherry picker. He's got a cherry picker, and he's up this huge mast by himself with no one around. What if he gets stuck up there?
Well, what if gravity asserts itself? Yeah. Yes.
The other test piece I've got is an old HMV Mantel radio, and
Okay.
I've disconnected the volume control and I've brought it out, so I've got the front end coming out to an RCA socket and the audio coming out to the RCA. So if you connect the two together, it'll work as a radio. But then you've got an amplifier you can feed into,
Yep.
or you can take the radio out and feed it into the audio stage.
Okay, so you can, so that I get the half split method. So you've got two good halves of the split, and you can sort of cross connect them and see which ones. Yeah. Okay. Nice. I reckon we're done. Thank you, folks.
I can also recommend
sorry.
some other YouTube sites. X-Ray Tony, he does radios, receivers and amplifiers, which he's excellent. Shango, who's a bit of a cowboy, but he's really entertaining. Shengo 066, I think it is, or something like that. And there's Graham, who's Radio Cruncher in England. He's really good. And then there's, of course, David Tipton up in Queensland.
Okay, I'll ask you later for those, Andrew, and I'll pop them in the next radio waves,
Yes.
just for everybody's reference. Okay, look, thank you very much. And that's the cue for afternoon tea.